Charles Babbage has invented this difference engine. Later on, after 10 years, he invented one more computing machine called analytical engine. If there is no any error, then that will be converted into machine code. Then it will come to the second line. Then same thing. So that is what will going to take more time than the compiler. That dark spots is considered as what? Pits. So if it is not filled by data, if we don't have any dark spots on that circular plate, then we call that as a land. Hello everyone, a warm welcome to one and all. I am here to discuss regarding the question paper of the year April-May 2022 of the scheme NEP CBS of the subject called Fundamentals of Computers in the first semester of B.Ca. I am Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So when it comes to the exam corner, it's mandatory in order to discuss the previous year question paper. Before that, let me give you the general instruction for it. As we all know that the maximum marks for this subject, that is Fundamentals of Computer, the maximum marks is for 60 marks. So totally it is for 100 marks. Your 40 marks your internals and 60 marks, that is what you are writing for your main examination. And what is the time duration? So for the time duration, you are going to get 2.5 hours. That means you will be getting 2 hours 30 minutes. That is what your exam duration. Fine. So now we'll discuss regarding the question paper pattern. As you all know that totally you are going to get only 4 questions from this question paper, and it consists of 2 parts. One is part A. So you have part A, along with we have part B here. So here we have part A and part B. In the part A you are going to get 3 questions. So in the one itself, you will be having 2 questions, that is A and B. In the A, you have 1 and 2 sub-question, or else you can write 1 and 2 sub-question from B. Same way we're going to apply for question number 2 and 3. So here, how we are supposed to choose? You have to write completely this question. That is what? You have to choose either A or either B. So not both. If you are writing one question from this and one more question from this, then you can't expect 15 marks. When it comes to the part A, you have to answer all the 3 questions and it will be for 15 marks. Totally it will be of 45 marks. So you are going to get 45 marks from part A itself. So you need to choose either A or B. So you have to write both the sub-questions of A if you are choosing A, and if you are choosing B, then you have to write both the sub-question of B. Same thing will apply for question number 2 and 3. That get over with part A. Then what about this part B? Part B is regarding 5 marks question. So here you need to answer any 3. So totally you are going to get the question number 4. There you have A, B, C, D and E. Out of this, you need to answer any 3. You need to answer any 3. So it is of 5 marks. Totally it will be for 15 marks. So 45 plus 15 will be totally of 60 marks. This is how the marks distribution. Then what are the general instruction you are supposed to follow? You should use ball pen. Don't go with a gel pen. What if something went wrong and if the content gets merged? So better you go with a ball pen and use same pen. And if you are changing a pen in between while writing the examination, please take a signature from your invigilator by saying that change of pen. Okay, preferably go with blue or black pen. Don't go with any of the gel pen here. This is what general instruction before writing the examination you all need to understand. I hope it's all clear. Let me go with a question paper discussion. So in that we have a part A. In that part A, what is the general instruction? Answer the following question. That means what? We have 3 questions from part A. You need to answer all the 3 questions, either A or B from each question. And each question carries 15 marks. 3 into 15, totally it will be for 45 marks. We'll see the question number 1. In that first question, write about the history of computer. And it is for how many marks? You can see it's for 9 marks. So you need to understand one thing. It can be 9 plus 6, 10 plus 5 or 8 plus 7. This is how the marks distribution, that 15 marks can be distributed in any of the way. So 9 plus 6, 10 plus 5, 8 plus 7 are the general distribution of a 15 marks. So here you need to understand this is for 9 marks. By looking into this marks, you have to write the content. What is the first question? Write the history of a computer. How the history of a computer evolved, how the computer has been evolved. First you need to understand. When it comes to that, first we have what? Abacus. In the year of 2500 BC, approximately 4000 years back, Chinese has invented this abacus, and it is considered as what? First machine which is used for counting and calculating purpose. So this abacus is considered as the first machine which is used for the purpose of counting and calculation purpose. That they started using this abacus for the purpose of addition, subtraction. Later they started using it for the purpose of even division and multiplication. Till now also we are using this abacus. After this what we have? So it got evolved with Napier bones. That was in the year 1614 AD. So here John Napier, he was a Scottish mathematician who invented this calculating tool. Moreover, we started using computer, or we started inventing computer for the purpose of calculation and counting purpose. So in that we got with abacus. After that we have this Napier bones. That was invented by John Napier. He was a Scottish mathematician. That person has invented this calculating tool. So whenever you are writing the answer for it, you just mention what kind of material they have used in order to prepare this and for what reason they were using it. For example, if you consider this Napier bones, so it was based upon the manipulation of rods with printed digit. So there they had rods with a printed digits, and rods were made up of bone, ivory, or any of the wood or any other metal. And here it has 10 rectangular blocks and with multiples of different digit on each 4 sides. It's like what? Dice. Okay, so that they were using for the purpose of calculation. So abacus, after that Napier bone, which is the next one, that is the slide rule. That was in the year 1633 AD. So whenever you are writing the history of a computer, mention its year and mention the name and mention the person, one who invented, and for what reason they were using and which material they have used in order to create this. So this slide rule was invented by William Oughtred. So mainly it is based on the principle that actual distance from the starting point of the rule is directly proportional to the logarithm of the number printed on the rule. So this is what the main rule they were using in this slide rule. So after this what we have? Adding machine, Pascaline. As the name indicates here, it was invented by a French mathematician at the age of 19. When he was at 19, name called Blaise Pascal. That person has invented this Pascaline in the year 1642 AD. And this Pascaline machine was first considered as what? First mechanical and automatic calculator. So this is what the main points you are supposed to write. Mention the year, mention the name, mention the person, one who invented it, and what are the materials they have used, what is the rule or any of the protocol they were using in order to use this, and how they were used, that and all you have to write here. Next what we have? In 1650, Leibniz calculator. So this is also going to be invented by this mathematician Gottfried Leibniz, which built a calculator in 1650 that could add, subtract, multiply and even divide the numbers. So for that reason, they have invented this Leibniz calculator. Later on, in the year 1801, Jacquard loom has been invented by Joseph Mary Jacquard. So whenever inventing something, they used to keep their names with a device name. That is what you can see here, Jacquard loom, invented by this person, Joseph Mary Jacquard. And it's a powered loom that uses punch wooden cards to automatically view incredibly detailed pattern, including pictures, text. So this can be considered as what? First read-only machine or a read-only memory. So once it is got printed or once the detailed pattern has been printed, then they can't change it. That is what happened in the Jacquard loom. After this, what we have? In the 1822, the revolution happened in the year 1822 by Charles Babbage. He invented two machines. One is different engine and another one is analytical engine. So here in the early 1820s, an English mathematician by the name Charles Babbage designed a computing machine called difference engine. This machine is able for the calculation purpose and printing simple math tables. So you can see the evolution from one device to another device which got evolved as a history of a computer here. Later on in the year, after one decade, that is what in the year 1830, he designed another one computing machine. Then we calling that as a analytical engine. First, that person, Charles Babbage, has invented this difference engine. Later on, after 10 years, he invented one more computing machine called analytical engine. And moreover, why do we call Charles Babbage as a father of computer? Because when he invented this analytical engine, that has all the 5 units. So that consists of 5 units which became the basic principle for the development of modern computer. It has input, output, memory, and it's also going to deal with the central processing unit. So it has all the 5 principles, basic principle, which is now used for the purpose of development of modern computer. That is what the reason the Charles Babbage is considered as a father of computers. Fine. Then how this analytical engine and difference engine come into existence? Who started writing code for it? So he invented some machine, but in order to make it work, we have to write a program. That was written by a beautiful lady called Lady Ada Lovelace. She is considered as the first woman in order to write the computer program, and who designed a program for Babbage's analytical engine. So it got evolved and it started working with the help of this person called Lady Ada Lovelace. In the year 1833, she took 3 years in order to write the code, in order to make it work. So after this, in the year 1890 AD, Hollerith tabulating machine. This was invented in the USA for the purpose of, in order to count the population of USA. This is how the history of computer evolved from one generation to another generation with different calculation tool they have invented here. This is how you are supposed to write the history of computer, and it is for 9 marks. I hope you all understood. If it is for 9 marks, obviously the next question will be for 6 marks. Totally 15, no? That's why. So what is the second question? Explain different types of computer based on size. Already you know the different types of computer. We have analog computer, digital and hybrid. So they are asking what is the different types of computer we have based on the criteria called size. Based on its size, we have to make a categorization. Instead of that, if you are simply writing analog, digital, hybrid and all, you won't get marks. Understand the question. Now they are asking what are the different types of computer we have which is based on its size. So based on the size of a computer, here you can see. So based on the performance, based on the size, based on the cost, capacity, the digital computers are classified into 4 types. Then what are the 4 types we have? We have microcomputers, minicomputers, mainframe computers, and also we have supercomputers. So these are the 4 types which is categorized based on the size. If they are asking the same question in different way, like based on the cost, capacity, then you can also write the same thing here. Understand, based on the performance, based on the capacity, cost, based on the size, these are the 4 types. Fine. So then this is for what? 6 marks. So you mention what are the different types of computer we have based on the size. After that, you write 2 to 3 points for each type and write the example along with 1 or 2 uses of it. So when it comes to the first one, that is microcomputer, it is also called as PC or a personal computer, and it was invented in the year 1970. Mention the type and mention the year and mention how it is working and how many number of processor they have. What is its processing speed? How many instruction it can process per second? That you mention along with 1 or 2 example. So you can see here it has a number of processors in microcomputer will be 1 or 2 processor. It has 1 or 2 processor. If the number of processors are more, then the number of execution of instruction will be more. So at that time, you can expect more access speed. So here also this contain input device, output device along with storage and processor. So here it can have 1 or more processor and can be used by one person at a time. Anyway, it is a personal computer, can be used by one person at a time. What are examples like desktops, PC, Macintosh, laptops, notebooks, tablets, palm tops, smartphone. These are the examples for this microcomputer. Then for the purpose of entertainment, and you can use it as a desktop in the office. So these are some of the examples, and moreover it is not so costly and it is user friendly. Next, what we have, mini computer here. Mini computers were invented in the year 1960s, and this is larger in size and more powerful than the personal computer. It is what mini computers are, more powerful than this microcomputer, and it can execute 5 million instructions per second. Very, very important. How many instructions can be executed per second? So it is able to process 5 million instructions per second, and also it consists of 2 or more processor, and it can serve up to 4,000 connected user simultaneously. This is multi-user, not for the personal computer. And also you can see some of the example, Digital Alpha, VAX 800 and AS 400 are the some of example which comes under this mini computer, and you can use in a small and medium size organization, and mainly we can use it for the purpose of data processing. What is the next type? We have mainframe computer. The size is very large in this mainframe computer, and it was invented in the year 1975. It's large computer in size, so it's more powerful than mini and macro computer, and it has multiple processor. So if it is multiple processor, then the execution speed is very high, and it will going to execute more number of instruction per second, and it performs multiple tasks, and then you can access the mainframe computer through the help of personal computer, and moreover it is not at all user friendly. You should have certain knowledge in order to use this mainframe computer, and just you can see here it can execute 16 million instruction per second. The previous one was able to execute 5 million instructions. This mainframe computer has the ability to execute 16 million instructions per second. And example are CTC 6600, NEC 610 and EC 10. These are the example for this mainframe computer. So here you can see some of the users, and this is not so user friendly, and it has a wide variety of software, even storage capacity is high. So it also have certain peripherals which is attached to it. This is what regarding mainframe computer. At last, what we have? Supercomputer, the fastest computer which was invented in the year 1980, and supercomputers as of now is the fastest computer, and it is biggest in size and most expensive in the price than any other computer here. And also, and it is more sophisticated, complex and advanced computer. Not all the user can use this. In order to use this supercomputer, you must have a thorough knowledge, and you should be trained in order to use this supercomputers. And also you can see some of the example, IBM Roadrunner, IBM Blue Gene, Param Padma. These are the example of this supercomputer, and we are going to use it for the purpose of animated graphics like Hollywood movies, and also for the purpose of weather forecasting and nuclear energy research, space science. So in order to have a more complex and advanced computation, there you can have this supercomputer. This is what you have to answer for 6 marks. So this is regarding the types of computer based on size. This is one part. So here we have question number 1. In that we have A and 2 sub questions are there. So we are done with this one. Either you can answer for this, or else I have a question number 1 with a option B. Let me check there. So in that we have a question number B. In the one we have a question number B. In that first sub question, what are the various computer languages? Explain. You should understand the marks distribution here. This is for 8 marks, correct? What are the various computer languages? So when you found this question mark, so before that, whatever the question they had given, that is for 1 mark. After that, they are asking you to explain. So that remaining 7 marks is for the explanation. So it will be for 8 marks here. Then how we are supposed to write? What are the various languages of computer? So you should mention what are the languages we have. Computer languages are classified into 2 categories. Mention this category, so you will be able to get 1 mark. mark for this. So we have two types or two category of computer language. One is low level language. Under that we have this machine level and assembly level. And we have a second type, high level language. In that we have a general purpose and specific purpose language. So you need to explain both low level and high level. So you can expect 3.5 marks for this and another 3.5 marks for this high level. Fine. So we'll see the first one, machine level language. As the name indicates, the language which understood by the computer on its own, which is machine level in nature. Then we call that as a machine level language. It is a fundamental language of a computer, and we are going to write the code in the terms of zeros and ones. A program written in the machine level language is considered as what? Machine code. Computer can understand this machine code or object code. The code which is written by the programmer is source code. The code which can be understood by the computer is machine code or object code. The instruction provided in the machine language are directly understood by the computer and converted into electronic signals in order to run the computer. So here when it comes to the machine level language, at the time it has two parts in it. One is opcode, second one is operand. Opcode specifies the operation code, what kind of operation it is doing, and operand specify the address or location of that number or that calculation. So first 4-bit represents the opcode, denoting whether it is loading kind of operation, loading, moving, storing, or halt, delete, stop, like that. Then the next last 8-bit is considered as the operand, that denotes the address of the location where it is happening. So here you can see one of the example for it. In order to add two numbers, we have this one. So first 4-bit we're going to represent the opcode. Next is what? Operand. You can see the example of this machine level language. After this, what we have? Assembly level language, which comes under low level itself. If it is a low level language, so there we are not going to expect, or we can't expect more user friendliness in the writing program. So when it comes to the assembly level language, it is also one of the low level language itself, and here users as to write a program by making use of letters, words and symbols, then we call that as a mnemonics here. So instead of using zeros and ones or a binary digit, we are using this mnemonics. If it is a mnemonics that consists of symbols, letters and numbers, this is somehow better than remembering zeros and ones. So here, whenever we are writing a program in the assembly level language, then we call that as a assembly code. Though it is not understood by the computer, then we require a conversion from assembly level language to machine level language. In order to make that conversion, we have a language translator. That is what I will be discussing in the next question. As of now, the language which we are using, or the program which is written in the assembly level language, is called assembly code. So here you can see one of the example. In order to add two numbers, we are taking two values and we are storing it, printing it, and at last we are stopping it. This is one of the example. So in the previous one, machine level language, we found only zeros and ones. Somehow it is difficult in order to remember zeros and ones. But here you can easily remember with a sentence or some symbols, numbers, like that. So it is more convenient than the machine level language. These are all what? Low level language. Next we have a high level language. In this, in order to make a programming easy, then they are going to use some familiar English words and symbols to write a code in order to make the computer understand what users are seeking for. So it will going to use English like languages, which is moreover easy to learn as well as to use. So in this also we have what? Two types, which is general purpose and specific purpose. Already you have seen the example. So here we have C, C++, Java, Fortran, QBasic, and also we have this Pascal. These are the languages which comes under this high level language. Anyway, we also require language translator in order to convert from high level language to machine level language, which can be understood by computer. This is how we are supposed to answer for 8 marks. I hope it's all clear regarding this types of computer languages. So here we have a next question. explain different types of translator programs. So till now we have learned what are the different computer languages we have. In order to make the computer understand, it can understand only machine code. So we have to convert high level or assembly level language to machine level language. For that we have this language translator. So this is for 7 marks. 8 plus 7 is 15 here. Then how we are supposed to write the answer? Let me check here. So here we have a language translator. Why do we require it? The translator that translates the high level language to low level language. In the low level, again it is to machine level language. So here we have a 3 types of translator, that is compiler, interpreter, and also we have assembler. So mention the what is translator. So you are going to get 1 mark, and remaining compiler, assembler and interpreter, you can have a distribution like 2 plus 2 plus 2. So you can see the translator, assembler, compiler and interpreter. Then how this assembler work here? This is what already you know what is assembly code. In order to make it understand, in order to make the computer understand, that has to be converted into machine code. So for that we have this assembler. So it's a system software which translates an assembly language program into its machine level language. So for that reason we have this assembler. You can see the example. We have TASM, that is TASM, Turbo Assembler. And also we have MASM, that is Microsoft Macro Assembler. We have a source code which is can be understood by programmer. By making use of this assembler, that will be converted into machine code. Then what about compiler? So we have a compiler here. Just imagine there is a small difference between compiler and interpreter. You just need to understand that. Remember, here I have a program with 5 lines of code. Whenever I am using this compiler, the program which is in the high level language, it will going to read whole program at a time and convert that into machine understandable form by the compiler. If there is any error at the time of compilation, you will get to know what are the errors we have. So, if it is interpreter, then it will going to check particular line. First line it will going to check. If there is no any error, then that will be converted into machine code. Then it will come to the second line. Then same thing. So, that is what will going to take more time than the compiler. So this is how compiler and interpreter differs in slight difference. So compiler that translates high level language, that is source code, into the machine level language called object code or a machine code. So moreover, it is going to read the whole program and translate that program into series of machine level language instructor here. So this is more fast and it will be very easy in order to compile the whole program at a time. So here you can see, so here we have a source code high. So by making use of compiler, that will be converted into machine language. First 4 codes are what? Opcode, next are operand. This is compiler. Then what is an interpreter here? You can see here it will going to read one statement of a high level language at a time. Then that will be converted into its equivalent machine code immediately, and it will going to take more time. So it is slower than the compiler. Why? Because if there is a number of lines, then it will going to take much time. So for that reason it is slower, and here you can see the example. Basic and prologues are the example which comes under this interpreter. I hope you all understood regarding this question of this language translator. Let me move to the next question. That's all regarding what? Question number 1. In that we had a discussion regarding 1A and B. Either A or B. You can go with any of the question, not both. So here we have a second question in that A. In that we have a sub question. Describe the functional units of a computer with a need diagram, and it is for 8 marks. So they only clearly mention that you have to explain the functional components of a computer with a need diagram. Whenever you are writing a diagram, use proper pencil and scale. You can write the content in pen itself, but use the pencil in order to make the functional components here. So first you need to understand this is for 8 marks. We also have some of the functional components like input unit, output, CPU and also memory. So you can distribute 2 marks for each. Along with that you should write the diagram for that. So here we have a basic function. First it has to take the input from the input device that needs to be stored in computer memory. After that processing and conversion has to take place in the CPU. Then it has to generate the output. This is how the sequence of execution of a program will going to take place in the computer functionality. Then what are the functional components we have? We have input unit, memory or storage, output unit, and also we have the CPU or a central processing unit. So with this diagram only, I will explain how to write the answer for it. So have a look clearly here. First we have a data. So whenever I am giving the input, that is what data that needs to be processed. Then only I can call that as what? Information. So we are going to feed the data with the help of input unit. If it is an input unit, then it will be a collection of input devices. So by making use of this input devices, we are going to give the data for the purpose of processing. Then it will going to reach to the CPU or a central processing unit. In the CPU, again we have three subcategories: control unit, arithmetic and logic unit, and also we have this registers. So control unit, what it will going to do? It will going to controls and coordinates all the activities of a components of a computer, how input is working, how output device is working, how the memory is working. Every control will be by this control unit. So after this, you can see the bidirectional. All these are dynamic. They all have a bidirection. So data will going to be transferred from one device to another device for the purpose of processing. And next we have a ALU, arithmetic and logical unit. All the arithmetic operation like addition, subtraction, multiplication, division, modulus, everything will going to take place in this ALU along with some of the calculation. So once the calculation got over, then we have this register. So registers are like buffer. It will going to hold the intermediate data which we took from input device and which needs to be processed and which has to be sent to the output device. Till that we have that intermediate data that will going to be stored in this registers. After the processing has been done, next we have to store that in the computer's memory. So for that we have this primary memory and secondary memory. If you wanted to store the data temporarily, then go with primary memory. RAM, ROM are the example for that. And we have a secondary memory. If you want to store a bulk amount of data, large amount of data, then we have this secondary memory. So you can see the bidirectional. After this, once it is stored, then that has to be displayed as a resultant to the output. So by making use of this output unit or a collection of output devices, we can execute it or we can display the resultant. It can be soft copy or hard copy. Then we are considering that as what? Information. This is what you have to explain. This input unit converts the external word to the computer. This output unit will going to build a communication from a program to the external word. So use all those codes and write the diagram properly and mention 2 to 3 points in each of the components of computer. We have input here and mention the example: joystick, keyboard, mouse, scanner, OMR, OCR, all these are examples for this input unit. And also we have a memory or storage, memory for primary and storage is for secondary. And also we have what output unit. There you can write the example like printer, speaker, plotter. So those are the example, monitor. And then what we have here, CPU. In the CPU again it consists of 3 components, ALU, control unit and register. Mention about it. Fine. This is how you are supposed to answer for the question, what are the functional components of a computer. Let me move to the next question. Explain secondary storage devices. So this is for 7 marks. So you can see the marks distribution. Explain secondary storage devices. Mention what is secondary storage device. Why do we use it? So as we all know that primary memory storage is not so enough in order to store the bulk amount of data. So for that reason we have to move with the secondary storage device, and it is also considered as what? Auxiliary memory. It has the ability to store large amount of data. And also this when it compares to the primary memory, this is not so costlier. So you can get it in affordable price and it has more memory space than the primary memory, and even larger capacity it has, and also it retains the information which is stored on it. Until we are going to delete it, till that the content will remain same in the secondary storage devices. Then which we have? So we have magnetic memory like hard disk drive and CD, pen drive, memory cards are most commonly used secondary memory devices here. And the time which is taking in order to fetch the content from that storage device, then we call that as a access time. We'll see the first type, that is regarding magnetic disk, as the name indicates. So here you need to understand, we have a magnetic disk, optical disk, and also we have a static or a portable disk. So when it comes to the magnetic disk, here we are using circular plastic plates on which some magnetic materials is coated. That magnetic material is used in order to hold the data and information here. It may comes in various sizes and material, and the capacity or a property of magnetism is used in order to store the data and on that magnetic surface. So here the disk pack normally consists of disk mounted on the central shaft. So you can see one thing will be like this. After that we have circular imaginary lines, and that is consist of what number of circular plates here, that will be divided into tracks, and each tracks are again divided into sectors. So the central shaft rotates a speed up to 7200 revolution per minute RPM. So it has the ability to run 7200 times rotation per minute here, and it will going to store the data on both the side, and it will going to divide it into that surface is divided into number of invisible concentric circle like this. Then we call that as a tracks. Again the tracks is divided into various section called sector. So whenever we wanted to store the data and information, it is necessary in order to understand what is tracks and sector. Then what are the types which comes under this magnetic disk? We have a hard disk and floppy disk. These are the example for this magnetic disk. Next we have a optical disk. After the magnetic disk, we have a optical disk. What is the methodology they are using in it? So it has a random access. You no need to go with a sequential manner. You can access the content wherever you want, and then removable disk on which data is written and read through the use of laser beam. So here we are using laser beam. In the magnetic disk, we were using some magnetism in order to store the data and information, but here we are using this laser beam, and it rotating disk which coated with highly reflective material. So if you see the CD, and if it is exposed to the sunlight, you can see ultimate reflective content there. That is what the example which comes under this optical disk. And also here the data recording on the disk is done by focusing on a laser beam on the surface of the spinning disk, which stores the data as a microscopic light and dark spots on the disk surface. So whenever we have a data, you can see some dark surfaces are. Then that dark spots is considered as what? Pits. So if it is not filled by data, if we don't have any dark spots on that circular plate, then we call that as a LANs. That is non-spotted circular disk here. So the process of recording the data onto the optical disk is considered as what? Burning. That is what we are saying, CD burning, DVD burning, like that. So here you can see the different types of laser disk, optical laser disk, CD-ROM, compact disk, read-only memory. So it can be what? CDR or CD-RW. So this is recordable, this is rewritable. Same way we have a DVD-ROM, digital versatile disk, read-only memory. Same way DVD-R, and also we have DVD-RW, and we have Blu-ray disk, read-only memory. So these are the example which comes under this optical laser disk. Next what we have? At last we have a portable storage disk or a static disk, which is used, or which is a more convenient way of storing bulk amount of data. So the portable storage device or PSD is a small hard drive designed to hold any kind of digital data. What are the examples for this one? Pen drive, and also we have memory cards. All those are the things which comes under this portable device storage. So it comes in various size from the 256 GB up to some of the terabytes. So those are the example which comes under this portable storage device. I hope you all understood regarding the answer for this question. Let me move to the next one. In that we have a B. First one, how the operating systems are classified, discuss. So as I told earlier, you have to write how the operating systems are classified, then discuss. We'll see the answer for that. First, we have a single user operating system. When an operating system or complete resource of an operating system is allocated for a single person, then we call that as a single user operating system. Then what are the example? DOS and Windows 95, Win 98, Apple Macintosh are the example. After this, we have a batch operating system here. Batch in the sense what? They are collecting a similar job and similar needs, then similar resource requirement, and they are giving that as a one batch. They are execute multiple number of activities which are similar in nature, which require the similar resource. Then that is grouped as a batch and they are giving that to the operating system for the processing purpose. So allows the user to create the batch and execute each batch sequentially, processing all the jobs of batch, considering them as a single process. Then we call that as a batch operating system here. Then where do we use it? For the purpose of payroll, forecasting, statistical analysis. There you can have this batch operating system. So you can see some of the advantages in it. You no need to wait during its execution. Once you fed into the execution, you can have your own work, and it is non-interactive mode of execution. In between you can't do any interaction there. That's why it's offline debugging. So those are the disadvantage. So what are the example? IBM system by 360, and also we have DOS operating system as a example for this batch operating system. So here you can see we have a job 1 to up to n that is fed into the operating system, that considered as different batches will be given to the CPU. So these are the way of writing answer for this batch operating system. Next we have a multi-programming operating system. When the capacity of a CPU is there to execute more than one program concurrently or simultaneously, then we call that as a multi-programming. After this, you can see the operating system. Here we have n number of jobs. You can execute all these simultaneously. Next, we have a multitasking operating system. Allow more than one program to run at a time. So you can use Word document, you can give it for printing, you can listen to the music. That is what multitasking operating system here. Then what are the example? Windows 98 and Apple's Mac operating system is an example for this multitasking operating system. And also we call it as what? Context switching. This is another name for this multitasking operating system. So you can see I can use MS Word, email, web browser. Everything can be used by making use of this multitasking operating system. Next, here we have multi-user operating system. We know single user. Then when a resource is used by more than one person at a time, then that is multi-user. It's an operating system allows multiple users on the different computers or terminals to access a single system with one operating system in it. So we have only one operating system, resource we have only one, but you can access all these resources with different computers with different terminals. Then we call that as a multi-user operating system. As the name indicates, so here allows many users to share the computer resource simultaneously, which is based on, refers to the allocation of computer resource in time slots. 2 seconds for this user, 5 seconds for that user. In the time constraint, they are allocating the resource of a operating system to several programs simultaneously. Then we call that as what? Time sharing. Unix and Windows are the example for this time sharing operating system. So you can see here we have n number of user. So at this point of time, this user 5 is using the resources. After a certain second, that will be given to user 6. This is how the time sharing operating system work. Next, we have real-time operating system. When you try to book a movie ticket, when you try to book a tickets in the railway and all, at that time they are using this real-time operating system. Here, it refers to a computer and a software system that responds to an event before an event become obsolete. So that means that response should be very fast. At the time, we are going to use this real-time operating system. In the weather forecasting and in the online transaction, we can use this real-time. Example, Windows CE, Symbian, Linux operating systems are the example for it. Next, we have a distributed operating system. As the name indicates, here we have a collection of autonomous computer or a individual computer which are capable of communication and cooperation via software and hardware interconnection. We are distributing the resources and we are using it. So, ATM centers are the example for this. distributed operating system. They have a same software, same hardware, and with different location. Same way we have a network operating system. Here it's a collection of software and associated protocols that allow a set of autonomous computer which are interconnected by a computer network. With the help of computer network, we are using the operating system which are distributive in nature. Example, Windows NT and Windows Server Linux. So this is how we are supposed to write the answer, how the operating systems are classified, and this is for 7 marks. We'll see the next question. Before that, you can see the threads. That means we have a different processes in this network which we are connecting it in order to work it. And we have a second question. Explain I/O devices of a computer. What it mean? I/O devices, that is input output devices, and it is for 8 marks. So consider 4 marks for input and 4 marks for output. Write any 4 input devices, write any 4 output devices. So that's enough. So in that, first you mention what is input device. Mainly it is used to feed the data to the computer, and we have keyboard, mouse, and scanner, and OMR, OCR, MICR. All these comes under what? Input devices, joystick. So all these are the example of this input device. With the help of it, you can write the answer. First we have a keyboard here. Most commonly used input device is keyboard. It is used to enter numeric data, character data, and all the kind of data we can enter with the help of this keyboard. And in this we have a punctuation key, special keys, functional keys in order to perform a specific task. And also we have a 101 to 104 keys which will be differ from one manufacturer to another manufacturer. And here we have different types of keyboard like standard keyboard, ergonomics, wireless, virtual, and also we have compact keyboard. These are the different types. So next what we have mouse here. Write the abbreviation of mouse, that is mechanically operated user serial engine. And then it is used as a pointing device. It's very small in size and more accurate in nature. When that mouse that consists of what? Small bar or infrared rays will be there that comes inside the mouse. So when it touches on the surface, at that time signal will going to be generated, that will be converted into what? Instruction for the computer. And we have 2 types of mouse, mechanical and optical mouse. So here we have a small rubber ball in this mechanical mouse, but in the optical mouse, there we are using laser beams that is more accurate and has no any other moving parts within it. That's what it is used as laser in order to detect the movement. This is regarding mouse. After this, what we have? Joystick. If I say joystick, you're all familiar with it. Why? Because we are going to use joystick for the purpose of gaming. So we have a pivots on a base and reports its angle and direction to the device. It is controlling. Then where and all we can use this joystick? It can be used in controlling machine like cranes and manless trucks, underwater unmanned vehicles, and for the surveillance camera. Who is going to rotate the camera? With the help of this joystick only, they are rotating the surveillance camera here. That is what joystick. After this, we have a scanner here. One more example for this input device. It's an input device which works more like a photocopy machine. It is going to scan the hard copy that will be converted into digital form. For that, we have this scanner. And also, I have mentioned some of the points regarding OMR or optical mark recognition or reader. You can write any of this one. So you can go with optical character recognition or OCR, and also I have some of the points regarding MICR, that is magnetic ink character recognition, which we are most commonly using in the banks in order to recognize that MICR number. So this is what different input devices. Next we'll see about the output devices. Why do we require? After the processing, the data and instruction has to be displayed as a resultant. For that we have this output devices. So here you can see some of the example which comes under this output device like a monitor, printer, plotter, speaker, so projector. All these are the example for this output device. So write some of the points regarding monitor, which is considered as what? Display screen or visual display unit. And here monitor will going to display the image, text or any other kind of data, and it will going to be have the smallest dot that can display on the screen called pixel. If you have n number of pixel or if you have more number of pixel, you can expect more quality. The resolution will be high and you can see the pixel dimension in the terms of 640 into 480 pixels, 800 into 600 pixel, and also we have standard 1024 into 768 pixel. And this monitor comes in various size, 12 inch, 14 inch, 17, 19, 20. 21. As of now, we have more larger than this one, and we are going to measure its size diagonally. So if it is a monitor, then we are going to measure the size diagonally. That is what. And then what are the types we have? We have CRT or a cathode ray tube, and LCD, liquid crystal display, TFT, thin film transistor, and we have LED, that is light emitting diode. These are the different types of monitor. We have a next output device, that is printer. Most commonly used output device, that is printer. It will going to print certain data on the paper. That means it is producing hard copy of it. So here we have a different kinds of printer, impact and non-impact. In the impact, again we have a line printer, dot matrix printer, and we have a non-impact printer. In that we have thermal, laser and inkjet printer. No need to explain the types of non-impact and impact. Just mention what is printer, what are the types, and what is certain points regarding this impact printer. So it will going to print by striking device against the inked ribbon. So it will going to have a water communication between the paper and the printer. That is what it will going to have some striking strategies. So it will be noisy. So examples, line printer, dot matrix printer, which comes under impact. And also we have non-impact printer. They are not going to use any striking device. So it is not so noisy. And the examples, thermal, laser and inkjet printer comes under it. This is how we are supposed to write the answer for the output and input devices. Along with that, we have a plotter here. Plotter is an output device that draws shapes on the paper based on the commands from a computer. Like whenever we wanted to have print the flex, or if you wanted to print large size of any of the content, then we have to go with this plotter. It's a special output device that is designed to produce sharp qualities and large size graphics in different color schemes. There we are going to use this plotters. And also next we have it has a multicolor plotter with different color pen, which is able to draw different colors or different content on it, and it is more expensive than the printer. The size will be larger than the printer. More commonly we are going to use it in the engineering application. This is plotters. And also we have a speakers here, that is also one of the output device, and the sound signals from an analog or digital are converted into audible frequency in the speaker and produce voice output, and also we call that as a audio data itself. So these are the different kinds of output and input devices which you can write in order to get 8 marks. I hope you all understood my today's session. We are done with question number 1 and 2 with 2 sub-questions. In my coming session of part A, I will be discussing regarding the question number 3. In that we have a 2 sub-question A and B. That is what I will be discussing. And let me discuss regarding part B. That is what 5 marks question. There we have 5 questions. Out of that, you need to answer any 3. Let me discuss all these in the next session. Till that, keep learning, keep on growing. Thank you.